Okay, so in this video, we are going to talk about how to calculate outstanding loan balance. We are going to learn about two methods, prospective and retrospective. So basically, we are going to look into future and then looking back to the past. Okay, so we'll learn about prospective and the retrospective. Methods about regarding outstanding loan balance. So when using an amortization method, the payments from an annuity whose present value is equal to the original amount of the loan. Okay, so so the payments form an annuity whose present value is equal to the original amount of the loan. Okay, so if I do a timeline, this is 0. This is receive the loan. Then once you get the loan, you have to pay back. So so let's say you are making level payment and level payment. So this is payments. Okay, so then the present value, when you take the present value for this payment, it should equal to the loan you received at time 0. Okay, so that's what this means. So in this section, we want to determine the unpaid balance or outstanding loan balance or unpaid principal at any time after the inception of the loan. So let's say I come somewhere like here, K, and then let me use a different color. And then at this point, maybe I want to pay off the loan and I want to know how much I am owed. So at this point, remaining loan balance. Okay. So that's called the outstanding loan balance or unpaid principal or unpaid balance. Okay, so we want to know how to calculate that. So actually there are two methods. One is you can look into the future and so you look into the future, or you can look back. You can look into the past. Okay. So this one become prospective and this one become retrospective. Prospective method is sometimes is usually what we use, but retrospective method also is a good method in some situations. So let's see. So there are two approaches to find outstanding loan balance: prospective method and the retrospective method. So first we are going to focus on prospective method. Under prospective method, outstanding loan balance at time t is going to be present value at time t of all remaining payments. Okay, so present value of all remaining payments. So if I draw the timeline, so here is the time 0 where you receive the original loan amount. And then here is some time k, and then this is the end. So you have these payments. So payment. And here also you have payment. So now what you want to know, the outstanding loan balance at time k. Okay. So when we talk about outstanding loan balance, we don't consider the payment made at that point. Okay, so payment made at this time point is excluded. So this payment is excluded. So basically, you are looking at the balance after that payment. Okay. So now under the prospective method, what's going to be present value of all remaining payments? So you take the present value. So if it is a kn, then this will be n minus k. So the present value of remaining future payment, that's called the prospective. So you are looking into future. Okay. So you're looking into future and present value of all remaining future payment. That's called the outstanding loan balance under prospective method. Okay. So it's kind of like easy. So if it is, for example, in at time k, if I want to get the balance, then if since these are level payment, it would be what? Payment A, and the time is n minus k. Okay, so it's basically if it's level payment and it's form annuity, then we can use this nice formula. So prospective method is really simple if you think about it. It's easy to use. Now, under the retrospective method, you look into the past. Okay, so let me draw again the timeline. So here is 0, here is k, here is n, some payment here, so it's 1, 2, and then this is k plus 1, all the way up to n. Okay, so let's say these are payment. And here you have payment. Here is a payment. And here is a payment. And here is a payment. And then at this point, you get the receive the original loan amount. Then you make the payment to pay it off. Okay. Original loan. So now what I want to know the balance at time k, bk. So bk basically exclude the payment made at that time k. Okay, so this is outstanding loan balance after k payment. Okay, right after. Okay, right after you make this payment, you want to know the balance bk. So under prospective method, you look into the future and you take that present value of future payment. Under retrospective method, what you do, you take the accumulated value at time t of original loan amount minus accumulated value at time t of all past payment. Okay. So what you can do, you take the bk accumulated value at time t of original loan amount. So let's say this is b0. Okay. So what's the accumulated value of b0? It's going to be b0, and it need to be grow all the way up to k. Okay, so it's 1 plus I to k minus. So this is what? This is accumulated value of original loan. Then I will subtract the accumulated value of all the payments. Okay, so I have these payments. So I can bring it back to here. How you bring it back to the future? You multiply by 1 plus I to the what? In this case, k minus 1. And then for this one, you multiply by 1 plus I to the k minus 2, so forth. Okay, so we have a symbol for that. It's basically annuity immediate. So you can write payment S. It's going to be what? SK, you know. So then this would be the retrospective method way to find the remaining loan balance, outstanding loan balance. So here you can see the formula. So this time they use N. The I is the effective rate. So I is the rate for this time interval. Okay, effective rate. And then here you can see future value of payment made at time t equal 1 to n. Okay, so you instead of k, they use n. So if I want, I can change this to k and this to k. So you get the same thing. P is the original loan balance, so you can replace it by B0. I use B0. So that's the retrospective method. So for this one, you look into the past. What is the present value of original loan amount? So you take the 1 plus I to the k, you subtract the present value of all past payment you made, and you get the outstanding loan balance. So let's do some examples and see how to use these two methods. So you have then you can learn all these techniques. So here it says a loan is being repaid with 16 quarterly payments, where the first 8 payments are each $200 and the last 8 payments are each $400. If the nominal rate of interest convertible quarterly is 10%, use the both prospective and retrospective method to find the outstanding loan balance immediately after the plus 6 payment are made. So let's draw the timeline and see what this means. So here is 0 and 1. First 8 payment are 200. Okay, so 6, 7, 8. These are 200. The last 8 payments are each 400. If the nominal rate of interest convertible quarterly is 10%, so it's I4 is 10%. By the way, the payments are made each quarter. Okay, so the rates and the frequency of payments and frequency of interest convertible, they are same. Okay, so they both are quarterly payments and quarterly convertible interest rates. So this one says I4 divided by 4 is 2.5. What that mean? This means effective rate per quarter. Okay. So for this quarter, it's going to be 2.5%. Okay, so then use both the prospective method and retrospective method to find the outstanding balance immediately after the first 6 payment are made. So we are standing here. Okay, so we want to know the B6. Using two methods, using prospective and retrospective. Okay, so let's use the prospective. So so under prospective method, this is what present value of all future payment. So what are the present value of all future payment? You can see right away there are 200 payments. So I can take the present value under rate of 2.5 plus I can first find the present value of 400 payment at this time point. Okay, so you are taking the present value to here. So what that would be? That would be 400. There are 8 again at 2.5. But then from here, you have to bring it to times 6. Okay, so you have to multiply by v square. Okay, so let's use our calculator. So by the way, what is v? V is 1 over 1 plus I, which is 1 over 1.025, because we use 2.5%. Okay, so let's use our calculators. Let me bring my calculator. For first one, for this one, what are the entries we need to enter? N equal to 100, N equal to payment is 200, rate is 2.5, COY, POY is 1, present value what we need, future value need to be set 0 then. Okay, so let's use that. Okay, so N is 200 payment, 0 future value, 2.5 rate. This need to be 111. And compute present value. So I get 285.48. You can forget about the negative sign because that's just saying they had to pay, because I enter the payments as 200 positive, so I get negative in there. Okay, so next one, let's calculate this quantity and then we take the, we discount it, okay? To get that one, I have to enter n equal 8, payment equal 400, and the rest is actually the same. So I over y is 2.5, COY, POY is 1. Present value what we need, future value is 0. So let's use that. N is 8, 400 payment. 0 future value. 2.54 rate. And this need to be 1. And then the future value. So compute. Not future value, compute present value. So 2,868. And so that's the percent value. Okay, so I need to multiply by v square. Okay, so 1.0252 negative 2 times. So let's see what we get. 5 times 1.025 to the power negative 2. I get 2,729.8517 1279, and I had to add this one. So plus 385.48. So total present value, the outstanding loan balance is 3,115.33. So that's the prospective method. Now you can see that we don't need the original loan amount. We do not need original loan amount. We don't need that. What do we need? We need payment size and number of remaining payment. Okay, we need that. So we need payment size, number of remaining payment, and actually we need the interest rate too. But we don't need the original loan amount, how much we borrowed at the very beginning. That we don't need to calculate the outstanding loan balance under prospective method. But when we go to the retrospective, this is going to be different. So let's calculate the retrospective method approach. So let me erase this. And then also let me erase the this. Okay, so under retrospective method, B6 is going to be what? Future value of original loan amount minus future value of all past payments. So what that mean? So let's say my original loan balance is B0. Okay. So then this means basically B0, 1 plus I2, 6 minus the future value of all past payments. So I made 6 payments. So 200 S6 under 8, which is 2.5. In here, I is actually 2.5. So, but the problem using this one is we need to know the B0. That means what we really borrowed at the very beginning. So that quantity you need to calculate first. So how you get B0? You can use actually, let's use let's calculate it. So from 0 One here is 200, up to 8, 200, 9, 400, 16, 400. Okay. So I'm going to, not 2000, 200. So I had to find the percent value of all these payments to get the B0. So at time 0, not time 6. So what's going to be 0? B0 is going to be 200. There are 8 payments. Under rate 2.5. Then I can take the percent value of 400 at time 8. But then I had to multiply it by V to the 8 because you have final percent value of 400 payments at time 8. So you need to bring it to time 0. So which means basically you have to multiply by 8. Okay. So let's calculate this quantity. So what I'm going to calculate only this one. Then I can use it again in here. So I don't have to do the same calculation twice. So how do you get A8 at rate 2.5? You would enter n equal 8. Rate is 2.5. Percent value what you need. Future value is 0. And I mean IOY is 2.5. Then COY, POY is 1. Payment is 1. Okay. So let's use this. And let's use our calculator and get the answer. Okay, so X1 is payment, 8 for N, 0 for future value, 2.5 for IOY, and then compute percent value. So it's going to be 7.17. Then, so this one is 7.17, and this one also 7.17. Then here V, that's 1.025. V8 is going to be. So let's use all of that and then get the answer for original loan amount. So I'm using my calculator. Please check this calculation because sometimes I may make mistakes with my calculator. So you can email me and let me know if I am making it any mistakes. So time 400 times 7.17. Okay, so I got this to be 3,787.901. Okay, so now let's calculate the balance. So let's apply it here. So this is 3,787.9011 times 1.0252, 6 minus 200 as 6, 2.5. So we have to calculate as 6. So how you calculate that? Payment is 1. N is 6. Actually, I can calculate this entire thing. Okay, so then payment is 200. Let me change this. So, payment is 200. N is 6. Rate is 2.5. Is 1. Future value, what we need, percent value is 0. Okay, because S, so you need future value. So let's use our calculator. Okay, so 200 payment, 0% value. Rate is 2.5. 6 for N, and then compute future value. Okay, so this would be 1,277.55. But you have to subtract it by this number. So let's calculate that. So time 1.025 to 6. minus 1,277.55, and I get 3,000. So the answer, once you do all the subtraction, I would get answer as 3,115.25. Okay. So which is very close to the previous answer. Okay, so there's small difference, but um, that's normal because we made some approximations, some rounding up and rounding down. So anyway, so the answer from both method, prospective and retrospective method, they should be very close. So here you see how the method we use. But the problem with retrospective method, you need original loan amount. You saw that we have to calculate B0. But in the prospective method, you don't need that. And then here also you need payment size in order to calculate the present, the present, the present value of all past payments or future value of all past payments. Present in that sense mean like you are right now, but you want to bring past value to the right now. Okay, let's do a second problem. This one says a loan of $1,000 is being repaid with quarterly payment at the end of each quarter for 5 years at 6% convertible quarterly. Find the outstanding loan balance at the end of the second year. So loan is 1,000 repaid with quarterly payments at the end of each quarter for 5 years. So N is going to be what? 4 times 5 is 20. So the payment size is not given. Actually, we can calculate it if you want. 6% converted quarterly. So what's the rate? So I4 is 6%. That means the effective rate would be 1.5. So for this 1/4 rate is 1.5%. Find the outstanding loan balance at the end of the second year. So that means what? So that means 1, 2, 3, 4. That's a 1 year. Then 5, 6, 7, 8 is the second year. Okay, so at this point, what's the outstanding loan balance? So that will basically be 8. You don't know the B8. So you can see that we need payment size regardless whether we are using retrospective or prospective method. So we know the loan amount, so we can calculate the payment size. So 1,000 is going to be what? 1,000 is going to be percent value of all these payments. So there are going to be 20 payment under rate 1.5%. So from here, let's calculate the payment size. I use your calculator. So I'm going to use my calculator. Okay, so percent value is 1,000. Future value is 0. Rate is 1.5. Then there are 20 payments. Then I would compute the payment. So it's $58.25. Okay. So now I can use prospective method to look at to calculate the outstanding loan balance. So B8 is going to be payment. How many remaining payments? 20 minus 8. Okay. Under rate of 1.5. The payment now we know is 58.25. So let's use calculate again. So I can set actually N to be 12 because it's already there. And the payment as 58.25. 0 for future value. And then compute the Compute the present value. 635. 35.26. That would be the outstanding loan balance using prospective method. So I use prospective method here. Okay. You can use any method, depending on the problem. Sometimes both are same. I mean, whether it's easy to use or not, same. But both are sometimes same. Sometimes one method is preferred over other. So it's depending on the problem. Okay, so in this problem, a mortgage loan is being repaid with level annual payment of 5,000 at the end of the year for 20 years. The interest rate on the mortgage is 10%. The borrower pay 10 payment and then is unable to make payments. So for 2 years. Calculate the outstanding balance at the end of the 12th year. So let's see. Here is time 0, time 1, time 10, 11, 12, 20. So the payment size is 5,000. So for this one, no payment. And this one, no payment. So then we need to know the at the end of the 12th year. So this is the end of the 12th year. So at this point, we want to know the remaining loan balance. So what we can do, first we can calculate the B0. So what would be the B0? So we borrow the loan promising $5,000 at the end of each year for 20 years. No? So B0 should be present value of those payments. So 5,000, a 20, and rate is right away given is 10,000 per year. I mean 10% per year. So it's not that hard to calculate this one. Let's use our calculator. So let me reset this. Okay, so payments are 5,000. 0 future value. 20 N. 10% for rate. So come to 8% value. So it's 42,567. Point, let's see. Okay. So now at time 12, I want to find the balance, no? How you calculate balance? I can use retrospective method. So I can bring the original loan, I can calculate the future value of B0 at time 12. So it's going to be B0, 1 plus I to 12. And then the future value of this 5,000 payment. First, I would calculate it up to this point. So that would be what? 5,000. Yes, there are only 10 payment under rate 10%. Then I have to take it to 2 years, no? So that will be 1 plus I square. Okay, instead of V, it's because you are taking the future, so you have to multiply by 1 plus I. Square time 5,000 S 10 and rate 10%. So let's calculate this quantity and see what do we get. So this one is 42,567.82 times 1.1 because rate is 10% to 12. 1.1 square. And this quantity you can use your calculator. Let me use my calculator and get the answer. So, first, second, reset. I usually reset my calculator just to make sure nothing in remaining in one of those cells and give me a wrong answer. So payment is 5,000. N is 10. Rate also 10%. 0% value. Compute future value. So 9,697. 0.12. Okay, so let's get the final answer. using our calculator. So it's 42,567.22 times 1.1 to the 12 minus 1.1 square times 7968 7.12, and I would get 37,174.6. Now, if you want to use a prospective method, okay, so let me use a different color. So for prospective method, what you can do, you can calculate the outstanding loan balance uh, at time 12. Okay, so here. It's going to be hard because of these no payments. Okay, so I think prospective method would be really hard. Because you need to incorporate that no payment. Actually, then you cannot make you if I are using prospective method, we have to recalculate how long will it going to be take to pay this again, because you can't pay now within 20 years by just paying 5,000. Since you missed two payments, the future payments are going to be increased if you really want to pay within 20 years. So for this particular problem, retrospective is better. Okay, so let's try this problem. So this one says a loan at 10% is annual has initial payment of 100 and 9 further payments. Okay, so initial payment of 100 and 9 further payments. The payment amount increased by 2% a year. So let's initial payment, I would assume at the end of first year, because when you're taking loan, you really don't make initial payment right away. Okay, so let's assume this one is 100. So this is 1, and then the 9 other payments. The payment amount increased by 2% each year. So 100 times 1.02, 100 times 1.02 square, and 100 times 1.02 to the 9. Find the loan balance immediately after the fourth payment. So here I want to calculate the B4. Let's use our prospective method since we use retrospective in early problem. So how do I get B4? If theory-wise, this is present value of all future payment. And I know the next payment. What's the next payment? Next payment is going to be 100 times 1.02 to the 4. Okay. So, but I have to bring it present values. So I have to bring it back to the time 4. So what do? I multiply by V. Okay. So this would be 100 times 1.02 to the 4 times V. Plus next one, 100 times 1.02 to the 5 times V square. And then the last one would be what? 100 times 1.02 to the 9 times V. If you take the difference between these two, 10 and 4, it would be 6. Okay. So let me write it here. So B4 is going to be, I can see 100 times 1.02 to the 4 times V is common factor, so I can take it out. Then I end up with here 1. Next one is 1.02 times V all the way up to here. 1.02 times 5 and V5. Okay. So there are 6 terms. So if I write this as R, then it's going to be what? 1 plus R plus all the way up to R5. And we know how to get the sum of those values. So it would be 100 times 1.02 to the 4e. And it's going to be 1 minus r to the 6 over 1 minus r. So let's use our calculator. We know all the quantities. What is V, by the way? V is using 10%. V is 1 over 1.1 and R is actually 1.02 times V. So now substitute values and get the answer. So let me see 1.02 divided by 1.1. So R is actually 0.927272. So it's continuing. So it's to the power 6. And this part would be 5.009. And then 100, 1.004, and V is number. I get 492. That's the answer. Okay, so here's another question. So this one says, a loan is being repaid with 25 annual payments of 300 each. With the 10th payment, the borrower pays an extra 1,000, then repays the balance over 10 years with revised annual payment. The effective rate of interest is 8%. Calculate the amount of revised annual payment. Okay, so let's draw the timeline and see how this looks like. So the original loan amount is not given, but we know the payment size is 300. With the 10th payment, so you have the 10th payment, the borrower pays extra $1,000. And then after that, and repays the balance over 10 years. Okay, so now once we do that, we get a new timeline. Starting 11, so new payment, because of this extra $1,000. So these are the revised payment. The effective rate of interest is 8%. Calculate the amount of revised annual payment. So we want to know the payment size. Okay. So let's see the balance at time 10. Okay, right after this payment, P10. Okay. So I'm going to use the retrospective method. Okay. So how do I get the retrospective method? Since I want to include $1,000, that's why I'm using retrospective method. Okay. Let's first get the original loan balance, B0. So B0 is basically 300. There are 25 at rate of, what's the rate? 8%. Okay, so this is B0, original loan amount. So let's use our calculator and get the answer for that. So payments are 300. There are 25 payments. 0 for future value. And 8% for rate. And we want to come to percent value. So it's 3,202. Let's see. 43. So now let's try to get the balance after all these payments. Okay, so B10 is going to be B0, 1 plus 5 to 10 minus, I have to find the the future value. So for 300 payments, those are going to be 300 S10 under the rate 8% minus 1000, okay? Because it's happened right here. So you don't have to multiply by anything. So let's see the B10. Rate is 1.08 to 10. Let's calculate this quantity. Let me check the B0 is right or not. Just want to make sure I have the numbers correctly. 300 for payment, 25 for N, 8 for rate, 0 for future value, 20% value. Yes. So now again, let's reset this now. Now I want to enter 300 for payment, 10 for N, 8 for rate, 0 for percent value, and I need future value. I get 4,000. So for this one, 4,345, 97. Okay, so let's use our calculator and then do this full calculation. Okay. So here we get 3,202.43 times 1.08 to the 10, subtract the 4,345.97, subtract $1,000. And the remaining balance at time 10 now, after the extra $1,000 is 1,567.8361. So now, so we know that here the balance is now 1,567.83. And we want to pay it using 10 payments. So let's calculate the new payment size. So B10 equal new payment size, we don't know. And we are going to make it within 10 payment under the rate 8%. So we don't know the payment size. So let's use our calculator again. So let me reset calculator. So what's the current balance? Present value 1,567.8361. That's the present value. And the future value need to be 0 because we want to pay off the loan within 10 payment and the rate 8%. And let's complete the payment size. It's going to be 233.65. That's the payment size. So not $300, but you pay only 233, so around $70 less. Okay, so I'm going to leave this problem for you, and then we will meet again with the next topic.